Nuclear energy. In today's world, everyone seems to have an opinion about it. But have you ever wondered how it works and why it is so important? Hi, my name is Andreina, and today I'm going to talk about the science behind these concepts, which is nuclear chemistry. First of all, we need to understand atoms. Atoms are composed by a nucleus surrounded by particles called electrons, which have negative charge. The nucleus is formed by protons, particles with positive charge, and by neutrons, which are neutral and have no charge. These protons and neutrons are crammed together in a tiny volume. The protons, having the same charge, repel each other, but for most elements are capable of remaining together. However, in some atoms, the repulsion forces are just too strong, which causes the nucleus to break up. This process is called nuclear decay. And when an atom decays, it emits different particles, and that's what we call radiation. All these reactions that change the composition of a nucleus are called nuclear reactions. Frequently, when we change the nucleus composition, we transform an element into another. For example, carbon can become nitrogen and sodium can become neon. This process is called nuclear transmutation. Nuclei that change their structure spontaneously or without any help and emit radiation as a result are those we call radioactive. Nuclear chemistry has many important applications in the real world. One of the most widely known is nuclear energy. Nuclear reactions produce a huge amount of energy, and power plants take advantage of this to generate electricity. They use a process called fission, in which large nuclei split into smaller parts. For example, when uranium is bombed with neutrons, its highly unstable nucleus splits, which not only produces energy, but also produces new neutrons that can split other uranium nuclei, allowing the reaction to continue. Besides energy, nuclear chemistry also has applications in medicine. For example, a technique called gamma knife can destroy tumors when surgery cannot access their location, by using particles produced by nuclear reactions. Nuclear chemistry has also been used in agriculture to eradicate pests and preserve food, petroleum companies to locate and quantify oil, and water desalination to remove salt from seawater and make it drinkable. On a different note, nuclear reactions produce dangerous radiation, which can lead to serious illness or death. Nuclear chemistry is important for technological advances in numerous fields, but it can also be extremely dangerous. For that reason, we need to use science to counter its adverse effects and to discover new ways in which we can use nuclear